All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use the question and answer tab there on your interface and submit your questions. We'll try to get to as many as we can near the end of today's webinar. We are also going to be doing a drawing at the end of today's webinar for 4 $25 Amazon gift cards, so please stick around. Hopefully you'll be one of our 4 lucky winners. And I would be remiss if I did not mention the very interactive chat feature that we have here on the interface. So I'll be chatting out the audience, and I hope you guys will please send in your questions, comments, suggestions, whatever you want to share with us. We'll be more than happy to give it a look. All right, with that, let's go ahead and kick off today's webinar, which is Solving Data Protection the DevOps Way. Our speaker today is Ram Vandepol, who is the Cloud Solutions Architect at Storage OS. Ram, very good to see you. Thank you so much for joining me today.
Thank you. That's my pleasure.
All right, I'm going to take myself off camera, put myself on mute, let you dive right into your presentation.
Thank you. So, welcome. And I think this topic, when it comes to data, is really important, data protection. So we all are facing the need of protecting our data because this is the precious part of any organization. That's with the data that we can do a lot of business. So just to think about the data protection, we need first to roll back a bit and think about Kubernetes and I would say the DevOps practices around Kubernetes, but also addressing how Kubernetes is working from a data standpoint. So Kubernetes is designed for stateless application, meaning that it's not designed to record state of an application. Think about an API manager, for example. When you query an API, the API will query another service, multiple different services, but it will not record the state. It will not record anything related to that request that you made to the API gateway or the API manager. However, lots of different workloads are in need of recording data. We call them stateful application, and those applications, like let's say a database or a content management system, will need to record that data somewhere in the cluster, in the Kubernetes cluster. Obviously, that's not going to be in the container because the container is just a read-only image, a bit like a zip file, but that you can't at all modify. So stateless application, no need of storage. Obviously, in this stack on the left side, you can see there's nothing related to storage. The world would be so easier if we were just sticking with that part of the stack, that part of the screen, the left side. On the right side, we have the stateful stack where we need to have some storage. And Kubernetes is not a storage solution. Kubernetes is not a storage orchestrator. Kubernetes is just trying to, well, and I say just, sorry for that, I'm doing air quotes here, is orchestrating, giving framework to simplify through abstraction layers the usage of all the different components in the infrastructure. So in this case, we added that nice shiny box with SSDs or NVMEs, maybe a SAN array, or maybe some virtual disks somewhere from an hypervisor or a cloud provider. And these will be used for your data to be recorded through the life cycle of your container. So there's 2 things that we need to address here, because otherwise we'll not be able to discuss about data protection the DevOps way. There's a legacy approach of doing things. And this is most of the time what we can find in enterprise. When we say enterprise company, meaning those companies that are maybe Fortune 500, Fortune 100, where you have a couple of data centers, you have a large investment in assets to the infrastructure. And you might have like OpenShift maybe deployed using potentially an hypervisor or maybe a cloud provider with some legacy storage, like a SAN array from, I don't know, maybe EMC, Hitachi, NetApp. It doesn't really matter. But when you do this, you are creating an anti pattern regarding Kubernetes, because everything is, as you know, everything is configured as a desired state from a Kubernetes perspective in a way called, in a certain way, using infrastructure as a code. DevOps practice here, infrastructure as a code. But the usage of external components that are totally, I would say, clueless of Kubernetes is not really helping in this situation. So even if you might have some CSI driver, and just as you recall, a CSI driver is a container storage interface for accessing disks within the Kubernetes cluster towards a legacy storage. It will not be as comprehensive of Kubernetes than I would say a Kubernetes native solution for storage, because you will still need to configure a massive amount of different things. Like if you go SAN, for example, a storage area network, you will need to think about configuring the fabrics. You might need also to do some zoning with the actual nodes. This is not something dynamic, because actually Kubernetes is an elastic compute distributed compute system. So you expect to add and remove nodes at any point in time. You might want to add like 50 nodes at some point in one go, because you have a large amount of data compute to accomplish. Like maybe you do some Elasticsearch crushing data, and you need that power to absorb all the data that you want to crunch. With that kind of approach, with a legacy approach, you will have the need of creating a very high velocity automation stack to make sure that you can keep up with what Kubernetes is capable of. So it's not really the best pattern that you can imagine to have. So, and that would be the same if we were having to have a failure regarding the actual cluster, the Kubernetes cluster. We'll need to go back to that approach of reprovisioning, reconfiguring everything on a different site, maybe a different data center, maybe a different cloud provider, if the company data centers are for some reason down, like a major let's say networking outage. In this case, you are already facing specific element of the stack that cannot be available in the cloud providers, for which your actual workload has been totally depending on. So that's quite a very challenging moment where you want to face a disaster recovery, or actually recovering your workload. So let's see how we can address this differently. And oh yeah, one thing also from a backup perspective, sorry for that. From a backup perspective, that's going to be the same also, because actually from all the different stack, thinking about it, you will you will protect the data only from the disk that are attached to the actual nodes of your Kubernetes cluster, and you will miss a massive amount of information regarding your workload. So in this case, let's say even if you have a full environment that is totally automated, and you have your backup environment, and you can back up your SAN array and restore it somewhere else, well, you're in good position. You restored your data, but actually you did not restore the workload, because you don't have anything related to your workload that can consume the data that you have restored. And I'm just going to mention a couple of things that needs to happen if you want to restore that workload. And and have access to the workload actually. So as you know, from a Kubernetes perspective, if you want to have access to your workload, let's say a DB or like a website or an API gateway, you will need to define an ingress to have access, so an endpoint to have access to the workload. You might have a couple of secrets related to the database that you want to have access to. You might also have a specific definition of a container and a specific version of that container that you need to run regarding the data that you have restored, and everything else related to the actual amounts and volume claim regarding the workload. All those information were not captured within your backup taken with the backup software that protected your data from a legacy standpoint. Everything from a data perspective has been captured and maybe restored on the different cluster, but all the API objects, and I'm insisting here because they are all API objects from the workload, are not. They were part of a totally different construct because they were saved and stored in the etcd instance of that Kubernetes cluster and was never captured by the backup software. So how can we address that differently? Well, obviously here I'm part of Storage OS. I'm going to take that example here. If you go full cloud native, or I would say Kubernetes native in this case, and I'm saying cloud native because cloud is not a place, it's a way of working. It's a way of addressing a desired state in a totally agnostic way so that you can take what you have defined as a desired state for one platform and just basically run it against another platform and it should run. This is the cloud way. Here, if we think about it for a moment, having such a layer means that if those two clusters were two different Kubernetes flavor, let's say the one was OpenShift and the other one was maybe GKE, the fact that I have a common layer there, which is totally agnostic of the cloud provider, totally agnostic of the actual infrastructure components that I'm using, totally agnostic of the Kubernetes flavor, it will give you the ability to have one way to address all your needs, to address your desired state for your workload, and make sure that that desired state can be portable to any other infrastructure. And that's what a cloud native data management layer is capable of. In this example, we have that storage OS data management layer, which is sitting on top of the nodes, taking all the storage that has been presented to the nodes. And it could be local disk, it could be still the SAN, the old SAN that you have, and you want to leverage the investment regarding that SAN, maybe some virtual disk, whatever it is. Actually, that management layer really doesn't care because it will just take the overall and make a pool of it and allow Kubernetes to just create volumes, persistent volumes in it in a very native way. No need of specific drivers, no need of specific CLI tooling, no need of specific automation. It will do it in a Kubernetes native way using standard Kubernetes native API. And wherever you're going to do it, it's going to be the same. The beauty of such a solution also is that when you want to expand your nodes, so meaning scaling up or scaling down, that solution will understand exactly what you're trying to accomplish because it's capable of speaking Kubernetes, and it's capable of looking at Kubernetes and understanding what's happening. So it's true also when there's a failure. When there's a failure, let's say here we have node 02 that's going to fail, and we're in the luck because we had a replica of our data in node 04. So automatically, our workload will be able to access that replica on node 04. But more than that, we will have a unique features that allow Kubernetes to reschedule already the workloads on any of the nodes. Here I pointed to node 04 because it's for performance purposes, I would like to have data locality, especially for database. I want to have a direct path to my volume. But what it means is that that data management layer will just contact the API from Kubernetes and say, reschedule it now on a different node because I'm available. The data is available, you can reschedule it. Instead of waiting for Kubernetes to time out on the node and making sure that everything is not available anymore and maybe try to reschedule schedule the workload later. So we will have that approach where you have a data management layer that speaks Kubernetes languages, understand the API and the health of the Kubernetes stack, and make sure to address the needs of your workload at any point in time. So if we come back to what we were mentioning earlier about all those API objects, it means that we have another layer of abstraction for the storage part, a layer of abstractions that renders a high level of capabilities in terms of being agnostic to the platform. So whatever you're doing, even if you were having encrypted volumes with a key stored in a KMS provider or external KMS, due to the fact that everything is related to the object, everything is addressable by an API. So at that stage, if you have the proper backup solution, you will be able to get all the information, all the desired state of the different API objects that represent your actual workload. So that's quite a unique proposition here. And if you do that, it means that in theory, you can take the definition of any cluster from an API object perspective and recreate another cluster with everything about the same. The only missing part here at the current stage is the actual capture of the data so that we can copy the data from one cluster to another. But I would like you to keep this in mind. It's all the API objects from that cluster on the left can be saved in a way that we can recreate everything related to a workload, maybe even actually the full cluster, so that we can, in case of disaster, reprovision that cluster as it was at the specific given point in time where we did the backup of these objects. So if we think about it a bit more, I was mentioning the data part. So we know that the API are available to define the actual workload. Everything related to the namespace, the ingress, the persistence claim, persistent volume claims, secrets, maybe some service accounts. So many different things that are necessary for your workload to be accessible maybe by another one, like an API or maybe a frontend. The only piece that we were missing is the actual backup, the capture of the data, so that we can have that data available to be restored somewhere else. And have that one-to-one match so that when we restore the overall, we will be having a full a full workload that we can reschedule without any problem and without the need to go manually make any modifications or trying to adapt regarding the platform on which we are, because it might be not the same platform. The version might be different from an API standpoint. Maybe we are in a GKE instead of an OpenShift, like we were mentioning earlier. So those elements are actually something that we should not care, something that the application team or the organization in general should not care, because Kubernetes is there to provide you that abstraction layer for every component, and it should include also the storage layer for that. So in this example, we have a Kubernetes backup software. So it means a native backup software that understands Kubernetes. And you have a couple of them. I would say two of them would be Valero and Kasten. So one is available as an open source project, and the other one is a commercial offering. And both will allow you to speak Kubernetes and backup and do restore, but also do some disaster recovery around your cluster. So the way it works is that it will capture all the information about the workloads from an API standpoint. It will capture all the data related to your workload. So in this case, we have database with a persistent volume, and the persistent volume obviously is hosting the actual data of the database. And this will be captured, packaged together, and will be offloaded to S3 endpoint. So S3 is an object storage that allows you to do some versioning and so on. Not to start any discussion around this, but this is I would say, an offering that you can find at AWS, Google Cloud, or DigitalOcean. You can have that capabilities of storing objects in these providers with the S3 protocol. This will allow you a couple of different things that we will touch point at later on. So in this situation, it means that because I've saved my state of the workload, and I saved this, I capture my data, everything is offloaded to I would say to a third party using the S3 protocol. If I was to lose totally my my first cluster, or maybe I just want to have a copy of that workload somewhere else, I can use the backup software and restore actually the I would say the assets that were packaged all together in that new cluster. So at that stage, even if you have some encrypted volume and you are still running the same data management layer, like storage OS in this case, restoring those keys will allow you to have access to that encrypted volumes. So this solution will allow you to take any workload and move it from one cluster to another, whatever is the actual provider, because you have that abstraction layer from a data management layer and from a backup layer to a backup software layer. Everything is speaking Kubernetes in a native way, and you will be able to restore your data in this way. So let's have a view of what does it mean really, because that's something that we discuss about different elements about Kubernetes, about storage. We discuss about backup and S3 and API objects. But the reality is that we discuss about all that technology part, but we have also something which is much more important from a business perspective. It's what we call a business continuity planning. This is, for an organization, a way to define the minimum set of applications that needs to run even if there's a disaster, so that the company can continue carrying its business, maybe a bit slower, maybe not in an optimal way, but it will allow the business to basically not shut down. And this is something that most of the time when we discuss with customers, we are looking into this to understand exactly what is the requirement. And a solution like Kubernetes with a data management layer being cloud native and native to Kubernetes, along with a backup solution, will allow you to have the full agnostic approach from a platform perspective, meaning that if your data centers are burning, and it never happened except for a couple of times earlier this year for a French cloud provider, you don't really care about exactly what is the platform, what is the cloud provider, what is the Kubernetes distribution. All those elements are irrelevant. You just want to restart your workload somewhere, because the idea of containers being fully portable, despite the fact you have data attached to it, you want to keep that, you want to preserve that portability. And this means that from a business perspective, it's really important to be able to restore that anywhere. In this case, we can define like any BCP, RPO and RTO, meaning that from a backup perspective, we can do backup every hours, once a day, whatever is your requirement, you can define it. No change there. You can define a critical application that you need to keep in business for the business to run. And this is where it's really impressive, because you don't need to restore 1,000 different VMs or a crazy amount of data to like, and I'm thinking about some solution where you would need to restore a full volume with multiple VMs and so on, representing maybe terabytes of data, and then only starting to look into this. No, here you can define per application. So like Kubernetes, you say, okay, I want my DB, this DB is very important, this front end is very important, that API is very important because it's for our payment processing. So you can really define the overall structure from a desired state perspective, and we'll see that in a moment, in a very granular way. So that's one. It's a check. Obviously, you have a backup strategy around this, and the backup strategy usually is coming with an approach about making sure that you have a point-in-time restore, and that you can restore this, and it will restore without the need of going into the application and do some modifications. The offload of the backup is also usually one of the most important part of that strategy, because if you do, even if you have two data center and you have a cross approach for doing the backup, we all know that it's not sufficient. We all know that at some point, for compliance reason, for security purposes, we would like to offload those backups somewhere else. I think that S3 provider is checking the box. By design, straight out of the box, you will already have an offload, you will have a copy of your data totally offloaded out of your data centers. So that's perfect. The other really important part is being able to recover those critical applications for your business. And as we saw, it's something that we can do it in a granular way. We'll see also from a definition, because I will show you how it looks like from a desired state perspective, that we will have also a lot of flexibility from an application perspective to make this happen. The last part is the side recovery or the full recovery of an environment. So meaning that, as I was mentioning, because everything is API and based on API objects, if you capture the overall desired state, well, actually it's the desired state at a point in time, you will be able to restore that specific environment anywhere, almost anywhere, to be honest. But from a workload perspective, you will be able to do it. So these are the key takeaways of having such a solution for solving the data protection. It's really solving the data protection in a GitOps way, and even in the DevOps way, actually. And the reason why, it's because one of the DevOps practices that we're looking here, it's both the infrastructure as a code, the ability to also integrate this in a GitOps way. And if we look into this, let's have an example of how it looks like from the deployment perspective. And I'm going to take like here, and I'm going to make it bigger. It's basically a stateful set. So it's the desired state to deploy a database on your Kubernetes. Okay. So as you can see, I'm deploying here Postgres a database on Kubernetes. The way I do the backup here, it's basically, I don't need to start looking into multiple different things, like going in an interface and starting to select whatever I want and so on. You will, from an application perspective, already say, okay, from my application, the most important part is this volume. and the volume is related to my containers. If you had multiple volumes, you can put them. If you have, for example, some multiple containers in your deployment, like maybe you have an init container to start a specific workload, you don't want to back up this, even if you were to use this. Even if you had to use some persistent volume for that init container, you would not need you don't need to back up that volume, so you will not include it there. Another important element is that when you do a backup, it's not about just taking a snapshot. We all know that taking a snapshot is not sufficient. There's a legend that snapshot help on everything and will solve the problem of everything from a deletion up to a disaster recovery. The reality is that if you don't have the ability to speak to the application, you will not be able to have a consistent backup. So one of the things that you want to do potentially is to do some pre-hook or post-hook. In this case, I didn't put the pre-hook. I'm just illustrating the post-hook, where I potentially have a file, and actually this is a way for me to inject, for example, a backup when I do a demo of an application. And so basically, when I do the restore, I say I want you to inject that database dump in this way, and so I can already mention a waiting time just to avoid the never-ending restore. And also, I want also to say I want to continue even if there's an error. So as you can see, it's really flexible, and everything is defined as code, as a desired state. So it's really easy to define exactly what we want. Another element that is quite interesting, and I'm going to take another example, it's this one. This one is for a front end. And for a front end, you would say, well, front end usually it's static file. And here I'm looking at Drupal. And Drupal actually is kind of a legacy CMS, content management system, which will do some generation of files, but you will also you can write blogs, upload images, and all those elements might not all be in a database at some point. They might be saved locally on disk. And so you want to also back up that part because it's an old way of doing things. But when you do the backup, you want to be able to avoid that there was some writing in progress at the moment of the backup. So to illustrate the pre-hook that I didn't do for the database, here I'm saying, okay, for my specific container, and as you can see here, I was mentioning an init container, and I'm having a container with Drupal, but I can potentially I could have like the database included here too. So I could say in a granular way for my container called FoodMac app frontend, here, execute in that container that specific freeze to make sure that I can stop all the writing happening on the volume. And in that case, it allows us to have a consistent backup. So that's the kind of thing you can do with defining straight from the beginning how your application behave, because you know how the application behave, you know how to proceed with the backup of your application, and you can just define that straight in your desired state, your definition of your stateful set here for that on that front end. So there's many advantages in doing this. It allows you also to do a self-service, and you have an understanding of how it works without the need to go through multiple stages of tickets and back and forth to make sure that everything is working. You can test it live, and that's a good way to do it. So that's a good way to do things, I guess. And that's about it for my presentation. So I'm gonna look if there's any question.
All right, now is the time for question and answer. If you've got a question for Ram, please go ahead and use the question and answer tab. Currently, we don't have any questions in, so I'm going to give the audience a second or two to go ahead and get some in. Come on, guys, I know you've got some questions. While we are waiting to see if we do get any questions from the audience, I do want to remind the audience that today's presentation is going to be available on demand. So if you want to watch the presentation again, if like Dennis, you came in late and want to watch it from the beginning, whatever your scenario, you will have the opportunity to access the webinar on demand. It should be available to you probably by the end of the day, maybe first thing tomorrow morning. So fret not if you missed any or all of the event, you will have the opportunity to watch it again. So Ram, you had such a great presentation. Nobody seems to have any questions for you.
That's okay. Maybe a question for the audience. Who is using either Valero or Kasten? And you can put a thumbs up in the chat.
Yeah, anybody who's using Valero or Kasten, let us know. Go ahead and put that in the chat. Also want to remind the audience that we are going to be doing a drawing for $425 Amazon gift cards as soon as we wrap up here. So please don't run away. Don't run away. I don't think anybody's using Kasten. What's up with that? Either that or everybody's.
Yeah. So that's quite interesting. Nobody's backupping data. Backup is obsolete.
Well, maybe that's what it is. Yeah, maybe that's the problem right there. So, all right. Well, yeah. So hang tight for just a second, Ram. I'm going to go ahead and do the drawing for the $425 Amazon gift cards, and then we will send everybody on their merry way, I guess. Today's gift card winners are Michael L. Congratulations, Michael. Our second winner today is Rod F. Congratulations, Rod. Our third winner today is Stephen L. Congratulations, Stephen. And our fourth and final winner today is Martin C. Congratulations, Martin. We'll be following up with all four of you via email to get your Amazon gift card over to you. So please check your inbox. And if you don't see anything there, please check your spam folder. Ram, what a great presentation. Like I said, it was so thorough. Nobody had any questions. So I guess maybe that's a good problem to have. But yeah, it was a great presentation. So thank you very much for spending your time with us and offering up your expertise. It's very much appreciated.
Have a nice day.
All right. I also want to thank the audience for joining me today because I'm going to give you 23 minutes back in your day. So I hope everybody enjoyed today's webinar, and we will hopefully see you again on a future webinar. But before I say goodbye, I do want to let the audience know also that the webinar, when it's on demand, is also going to be living on the DevOps.com website. So you can always go look for it there. Just go into the webinar section, look in the on-demand section, and it should be right there waiting for you. So with that, I'm going to go ahead and end today's webinar. Thank you very much for joining, everybody, and we'll see you next time. Have a great day.